We will now attempt to solve this question. The question is, an electrician has to repair an electric fault on a pole of height 5 meter. She needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. What should be the length of the ladder that she should use, which, when inclined at an angle of 60 degree to the horizontal, would enable her to reach the required position? Also, how far from the foot of the pole should she place the foot of the ladder? You may take root 3 equal to 1.73. If you look at this question, there are actually two questions here. The first question is, what should be the length of the ladder? And the second question is, how far from the foot of the pole should she place the foot of the ladder? So let us begin solving this question by drawing the diagram. So let us suppose this be the pole, which we can name as AB. AB is the pole, and this point, let's suppose this is this point C, which is 1.3 meter below the top of the pole. So this is A is the top of the pole. C is a point 1.3 meter below the top of the pole. Let us suppose this is the horizontal position where the ladder will be put, and let us suppose this is the ladder which has to reach the point C. Okay, we can name this point as D. All right, and this ladder, so CD is the ladder here, and as per the question, this is inclined at an angle of 60 degrees. So this particular angle here is 60 degree. Okay, so what we need to find here is that what should be the length of the ladder. That means we need to find the length of CD. CD is the ladder here, and AC, this value is given as 1.3 meter. So we need to find CD, the length of the ladder. And the second question is, how far from the foot of the pole should she place the foot of the ladder? So CD is the ladder, D is the foot of the ladder, and how far the foot of the ladder is from the foot of the pole. B is the foot of the pole. So we need to find BD. All right. So let us start. We first make a note of the given parameters. AC, sorry, AB is equal to 5 meter. The length of the pole is 5 meter. AC is equal to 1.3 meter. We can both write in the same line. Angle ABD, or you can say CBD, equal to 90 degree because the pole is vertically above the ground. Angle CDB equal to 60 degree as per the question, which is nothing but the angle of elevation. Okay, here we need to find CD, which is nothing but we can mark as, since this has two questions, so I can say first one, to find CD, the length of the ladder, and the second one I need to find BD, the distance of the foot of the ladder from the foot of the pole. Solution. This question is of trigonometry. To solve these kinds of problems, we need to know a few things in advance, like trigonometric ratios of a right angle triangle according to which sin theta equal to opposite by hypotenuse, cos theta equal to adjacent by hypotenuse, and tan theta equal to opposite by adjacent. We also need to know the trigonometric table of common angles, the one that is shown on your screen. Furthermore, sometimes we also need to know the Pythagoras theorem according to which hypotenuse square equal to perpendicular square plus base square. Now, as we know that angle ABD is 90 degree and angle CDB is equal to 60 degree. So we can take the triangle CBD from triangle CBD. We have tan theta equal to opposite by adjacent, which is opposite is nothing but CB by, and adjacent is nothing but BD, which is equal to AB minus AC uh, upon BD, or we can say here theta here is tan of 60 degree equal to AB is given as 5 meters. So AB minus AC, we can say 5 minus 1.3 and divided by BD is equal to 5 minus 1.3 is 3.7 by BD. 1060 is how much? 1060 is, we know that it is root 3 equal to 3.7 by BD, which implies BD equal to 3.7 by root 3, or 3.7 by root 3 is given as 1.73 equal to, so we calculate this value 3.7 by 1.73, this will come 2.1387. So BD is the BD is, we need to find BD in the, as per the question. So BD is nothing but the distance of the ladder from the distance of the foot of the ladder from the foot of the pole. So this is the answer for the second question. Okay, this you can mark as 2. Now we need to find CD. Okay, so here we know the value of CB you have found it here. So CB is nothing but AB minus BC. So this is 3.7. CB is 3.7. So we know C for question number 1. What we can do here, to that means 1 is nothing but the length of the ladder. For the length of the ladder, that means number 1 we can put here, number 1 length of the ladder. We can say sine theta, we know that opposite by hypotenuse. Opposite is nothing but here CD, sorry, opposite here is BC, BC by CD. BC opposite is BC, and hypotenuse, we know hypotenuse is CD. So hypotenuse in the triangle is CD. So what is BC? What is BC? BC is this one, 3.7. So BC is 3.7. So we can say sine of 60 degree. So we, or you can say, sorry, you can say here BC is 3.7, or CB or BC 3.7 by CD. CD, the length of the ladder. Sine 60 is root 3 by 2. So we can say sine of 60 equal to 3.7 by CD, or which implies root 3 by 2. Sine 60 is root 3 by 2 equal to 3.7 by CD, which implies, as we know, need to find CD. So CD is equal to 3.7 into 2 by root 3. So it becomes 3.7 into 2 by root 3 is given as 1.732, right? Root 3 is given as 1.73, 1.73 or 1.732, 1.73, 1.73. So if you calculate this one, we will get 3.7 into 2, it becomes 7.4. So we can say 7.4 divided by 1.73, which becomes divided by 7.4 divided by 1.73. This is 4.27. So 4.277 meter. So this is the length of the ladder. This is first one, and then the distance of the foot of the ladder from the foot of the pole is this one, okay, which is nothing but BD. BD. So we have found BD here, and we have found CD here, and this solves the problem. Thank you very much.